Alright, in this lesson we will learn how to prove whether or not two triangles are similar. There are three different ways to prove that two triangles are similar. One is side-side-side similarity. If all three pairs of sides are proportional, that just means they're going to all make the same ratio if I make fractions out of them. For example, 10 over 5, 10 and 5 are corresponding sides, and if I do 10 over 5 as a ratio, I get 2. 6 and 3 are corresponding sides, and if I do 6 over 3, I get 2. 12 and 6 are corresponding sides. If I do 12 over 6, I get 2. So this is what it means when I say the all three pairs of sides need to be proportional. So that would be side-side-side similarity. By the way, these three ratios that all turn out to be the same, this is called the scale factor. So we would say the scale factor is 2. Alright, and in this context that means that the big triangle is twice as big as the small triangle. Anyway, in addition to side-side-side similarity, we can prove that two triangles are similar if they have two angles that are the same. Like 65 and 30, the small triangle has degrees 65 and 30. That's enough to prove that these two triangles are similar. And the third and final way to prove that two triangles are similar is side-angle side similarity. The S and S again refer to the sides being proportional. So I mean, I used the same number, so we've already done the math, but these are still proportional, meaning that the 10 over 5 equals 2 in the same way that if we've got the 12 and the 6, again 12 over 6 equals 2. So we have two pairs of sides that are proportional, and then one angle that is congruent. It's important that the angle that is congruent is between the sides that are proportional. So that gives us our side, angle, side. If this 30 degrees in here were somehow on a different angle, so if I took this 30 degrees and put it over here, for example, these two triangles would not be similar. Even though I have two sides and an angle, and here I have proportional two sides and an angle, it's the wrong angle. Okay, even if the 30 on this triangle were also moved. Okay, even if this 30 were also over here. Still, these two triangles are not similar. We cannot be sure that they are similar. Okay, it has to be two proportional sides and the angle that's between them, not the angle that's off to the side. Alright, so for problem number 1, we're supposed to figure out which of these triangles are similar. So we're given only sides, so obviously we're looking for side-side-side similarity. So we have to check and see if the sides are proportional. So I think the best thing to do is just to look at two triangles at a time. So I'm going to cover up this triangle and use this space as a space to write. Okay, so let's check and see if corresponding sides are proportional. So I'm going to color code this. So I've got these green ones are corresponding, and let's see, these pink ones are corresponding, and let's say these blue ones are corresponding. So I'm going to make the green fraction, the pink fraction, and the blue fraction. If these are similar, alright, by side-side-side similarity, all three fractions should be the same, right? That's what it means to be proportional. So first of all, the green pair. So that would be 8 over 6, alright, which of course reduces down to 4 over 3. Okay, now let's do the pink pair. Okay, so that would be 12 over 7.5. Okay, 8 over 6, 12 over 7.5. Okay, let's check that in the calculator. So 12 over 7.5. Decimal toggle. Well, that's 8 over 5. Okay, so right there, that means these two triangles are not similar, alright, because these sides are not proportional. So I can stop there as far as these two go. So that's a big no. Alright, so let's check these two now. So again, if these two are going to be similar, then the corresponding sides should be proportional, which means if I make fractions out of the corresponding sides, I should get the same answer over and over again. So let's do the greens, the pinks, and then the blues. Okay, so the greens, again, so I've got 6 over 4, okay, which reduces down to 3 over 2. Now let's do the pinks. Alright, so the pinks, so that would be 7.5 over 5. Let's see what that is. Okay, 3 over 2. Alright, same thing we had before. So far, it's looking good for similarity. But it has to be all three. So let's check the blues now. That would be 4.5 over 3. Let's see what that is. And once again, 3 over 2. Okay, because we got the same ratio all three times, that means that these two triangles are similar by side-side-side similarity. So let's make our similarity statement and say that triangle NPM, so triangle NPM is similar to triangle PSQ. PSQ. Okay, and that is how you do it. Let's look at that again. Let's do number 2 the same way. Alright, looking at number 2, I've circled the corresponding sides with like colors. Let's see if the corresponding sides are proportional by seeing if we make these fractions, will I get the same ratio every time? So the greens, that's going to give me a ratio of 8 to 10, which reduces down to 4/5. Okay, now the pinks, that's a ratio of 4 to 6, okay, which reduces down to 2/3. Already those are not the same, but OCD compels me forward. 10 over 12 reduces down to 5/6. So these are clearly not proportional because I did not get the same ratio every time. So that means these two triangles are not similar, so I can forget about that. Alright, let's check these two triangles. Alright, let's do the greens. So that would be 10 over 20, which of course is 1/2. What about the pinks? Okay, for the pinks, that would be 6 over 10. But that would be 3/5. So this is also a fail. Alright, let me just follow through. 12 over 25, that doesn't even reduce. Alright, just stays 12 over 25. So these two triangles are not similar either. Does that mean nothing is similar? Well, let's check the first triangle and the last triangle. Alright, corresponding sides. So the greens would make 8 over 20. 8 over 20, alright? That's going to be like 2/5, right? 8 over 20. Okay, so that's 2/5. Alright, now let's do the pinks. That would be 4 over 10. Okay, divide those by 2, and that's definitely 2/5. So far, so good. Now let's do the blues. That would be 10 over 25. Okay, divide these both by 5, and guess what you have? 2/5. So these are clearly proportional. So that means these two triangles are similar. So my similarity statement will be like this. So we'll just do a triangle DEF. So triangle DEF is similar to triangle GHJ. Okay, so that's the answer to number 2. Alright, let's take a look at number 3. Let us be a little bit careful with number 3, especially you see how it's all turned around, and this one sort of looks upside down compared to the first one. So it's beneficial to ask yourself which one of these is the largest of the 3 sides. I'm looking at these 3 numbers. I'm seeing that 33 is the biggest. So I'm going to put a green on that one. Now, look at your second triangle. Which one of these is the biggest of these 3 numbers? Well, that is your 40. So that's a way of knowing that those are going to be corresponding, biggest with biggest. Now let's skip to the smallest. Back here, clearly 18 is the smallest of the 3. And okay, here 22 is the smallest. So those would be corresponding. And then look what's left. Alright, that leaves the 27 and the 30 to be corresponding sides. Alright, so that'll help you match things up properly. So now let's see if they're proportional by making ratios of corresponding sides. So first let's do the greens. So the greens will give us 33 over 40. Okay. Yeah, I didn't think you could do anything with that. Yeah, that's all you get, 33 over 40. Okay, doesn't look real promising, but we'll see what happens. So next, let's do the pinks. So that would be 18 over 22. Okay, and that's going to reduce, alright, that's going to be 9 over 11. Okay, so those do not match. So I already know that these are not going to be similar. I'm just going to follow through though. So this would be 27 over 30 divisible by 3. Okay, so that would be 9 over 10. Okay, these are not the same. So these triangles are not similar. Now let's compare the first triangle and the third triangle. Let's see, we're using green for the biggest. Okay, so that is the 44. And we're using pink for the smallest. Okay, and that's 24. So I'm glad we're being careful. If we weren't careful, I might have thought that the 18 and the 36 would match. Okay, because they're both on the left. But no. 18 is the smallest and 24 is the smallest, so they have to match up. They have to be corresponding, I should say. And that leaves the 27 and the 36 to be corresponding. Okay, so let's check these. Start with the greens. Alright, so that would be 33 over 44. Okay, both of these are divisible by 11, so this would be 3/4. Okay, let's do the pinks. Alright, that would be 18 over 24. Okay, both of these are divisible by 6, so that's going to be 3/4. This is looking really good. Now let's do the blues. Alright, that would be 27 over 36. Okay, both of these are divisible by 9, so that's going to be 3/4. Okay, if you have to use your calculator for any of these, alright, so for example 27 over 36, don't forget that you could. 27 over 36, okay, that's 3/4, like I said. Alright, because all of these are the same, that means that these two triangles are similar by side similarity. Okay, so we'll make our similarity statement. Triangle. I'm covering up part of it. Hold on. X, Y, Z. Okay, triangle X, Y, Z is similar to triangle. Now, slow down. Slow down. You got to be very careful. Remember how this is all sort of backwards and stuff. Okay? Look. These are sort of mirror images of each other. See the blues on the inside and the pinks on the outside, like mirror images. So the X is corresponding with the T. Okay? Like they're on opposite sides. So when I put the X, I'll put the T in that position. Alright, the Y is corresponding with angle S. They're both like facing towards each other. So I'll put the S in that position. And that leaves angle U. Alright, you just got to be very careful about the order. Alright, I think that's going to be a good place to stop this video. There are more examples coming that are similar, but so far we've done strictly side similarity. In the next video, we'll some of these are still side, but we'll look at angle similarity and side similarity as well. Okay, so that's coming up on the next video. I'll see you there.